All right, we're on page 2 now. So we're talking about perimeters and shapes and areas of shapes. So to find the perimeter of a certain shape, what you're going to do is add the length of all sides. So you're going to add up the length of all sides. Well, looking at a perimeter looking at maybe a square on a sheet of graph paper or on a coordinate plane, how are you going to find the length of each side? What should you use? You should use the distance formula. Distance formula. Sorry, my handwriting was so bad I just had to start over on that one. All right, and remember the distance formula is d is equal to square root of parentheses x2 minus x1 squared plus y2 minus y1 squared. And you can use Desmos to actually evaluate whenever you're putting points into this distance formula. So if you're doing a square, you would only need to do the distance formula one time. And why is that? Squares have equal side lengths. So you just need to find the side length of one, and then you know all of them, right? All right, areas of shapes. You're going to multiply. Specifically, you're going to multiply base times height. If it's a rectangle, you're going to do 1/2 base times height. If it's a triangle, and you're going to do side squared if it's a square, because side times side is the same thing as base times height, right? Remember the height with the triangle is wherever the right angle is. All right, what should you use? What do you need? So you're going to need the base and the height, or the side length. And you can find all of these using the distance formula. All right. Proving the shape. I know how you all love to win arguments, so let's win an argument about proving this shape. All right, rectangles, opposite sides are parallel. Opposite sides are also congruent. And you have 4 right angles. One more characteristic about a rectangle, I'll put it up here since I ran out of room. Your diagonals are congruent. Diagonals, there we go. All right, so looking at this, how could I prove that diagonals are congruent? And when I say congruent, I mean they're the same, right? They're equal, the same length. So to prove that the diagonals were congruent, I could use the distance formula. All right, distance formula. So if I use the distance formula between 2 points, right, and they end up being the same distance, I can say they're congruent. All right, so how would I prove that opposite sides are parallel? All right, you'd prove that opposite sides are parallel if they have the same slope. Remember, that's the criteria for parallel lines, right? They have the same slope. So if they have the same slope, their m will be equal. And I'm going to write down 2 different formulas for m for slope, rise over run. So how far you went up or down between the 2 points and how far you went over. If you want the exact formula, it's your change in... I drew that y and it kind of looks like an x. Y2 minus y1 over x2 minus x1. So just label your points and plug them into the slope formula. And if they have the same slope, then they're parallel. All right, how could I prove that opposite sides are congruent? Again, if I'm proving 2 sides are congruent, I need the distance formula. Once I get the distance of both sides, if the distance is equal, then the sides are congruent. All right, how could I prove 4 right angles? If the sides are perpendicular. Remember, perpendicular lines form 4 right angles, right? So how would I know if lines are perpendicular? Their slopes would be the negative reciprocal. So I'm going to say slopes are negative reciprocal. And we'll discuss that more down here. So just make a note of that for now. All right, so those are the different criteria of rectangles. All right, let's talk about right triangles. Well, I know that triangles would automatically have 3 points instead of 4 points, right? And then what do I know about a right triangle? It has one right angle. And again, just like how I proved with a rectangle having 4 right angles, I can prove one right angle if 2 sides of the triangle are perpendicular. And again, perpendicular means slopes are negative reciprocals. And I'll talk about what negative reciprocal means in a minute. So hold your horses. All right. Another part of Unit 5 is writing equations of parallel and perpendicular lines. So parallel lines, we already said before, have the same slope, right? And then perpendicular lines, negative reciprocal. You change the sign and flip them. All right, so we're going to write an equation of a line parallel to the line above. Well, this line is in slope-intercept form, which you should have remembered from algebra, y equals mx plus b. So let's identify the slope here. It's the m, which is the coefficient in front of x. So my slope is 5. So a parallel slope will also be 5. It'll be the same thing. All right, so if I'm going to write an equation of a line parallel to the line above, all I need is for it to have the same slope. Now my y-intercept here doesn't matter. If I'm writing an equation of any line parallel to the line above, I have infinitely many options. I could keep writing equations all day long, but I know you don't want me to do that. So y equals 5x. Let's do minus 2. You could have a different answer than me right here. You could have a different number, and it would still be right as long as the slope is 5. All right. And I'm going to go ahead and write the slope formula again, just so you have it. y2 minus y1 over x2 minus x1. Or the change in y's over the change in x, right? Rise over run. All right, perpendicular is the tricky one. That's your negative reciprocal. So my m here in this line is the same thing. It's the same equation, 5. Now my perpendicular slope I got to change the sign and flip it. So I would write 5 as a fraction as 5 over 1. 5 over 1 is the same thing as 5. Why is that the same thing? 5 divided by 1 is still going to be 5. All right, so if I'm going to flip this fraction and change the sign, my perpendicular slope is going to be a negative 1 over 5. This was positive, now it's negative. This was 5 over 1, now it's 1 over 5. So let's plug in the perpendicular slope to this equation. Y equals negative 1 over 5x, and we can use the same y-intercept as above here, minus 2. All right, let's try one more example. What if I gave you a slope of negative 1 over 2? What would your perpendicular slope be? Think about it, write it down. It would be a positive 2. Now you could have written 2 over 1, but its most simplified form is just 2, because 2 divided by 1 is just 2. So I change the sign and I flip the fraction. All right, great work. And we'll do some application problems in a minute. All right. Finding equations of parallel and perpendicular lines. You're going to identify if you want a parallel slope or a perpendicular slope. And remember, you're going to plug your m in for the slope. And you're going to be given a point that's got to be on the line, right? So I would set up an equation, y equals mx plus b, and plug my slope in for the m, and plug the point in for the x and the y. That's how you solve for b. And then after that, you're going to write your final equation. And again, we'll do some work with that on the problems page in a minute. All right, partitioning directed line segments. So I'm sure Ms. Strickland's class used these steps right here with labeling your points and converting the percent into a ratio. My class used the formula from the formula sheet. So I uploaded the formula sheet to Schoology. I also have it right here. So remember, we used this very first formula, coordinates of a point which partitions a directed line segment. So I'm going to go ahead and write that down on the paper. X comma y is equal to b times x1 plus a times x2, all divided by b plus a. And then the y coordinate is by1 plus ay2 all over b plus a. All right, I wrote that down. Now remember, this looks like a big formula here, right? So I told my class you need 6 things. You need an a b, an x1, an x2, a y1, and a y2. All right, the a and the b come from the ratio, right? So if I gave you an example of a ratio of 2 to 3, your a would be 2 and your b would be 3. All right. If I gave you example points of 0, 1 as your first point and 2, 3 is your second point. Order matters, right? Because it's a directed line segment, which means it's going in a specific direction. So this would be your x1, y1, x2, y2. 0, 1 from this point, and this would be 2, 3. These are the 6 things you need to plug into this formula up here. Now remember, the formula looks crazy, but this right here is your x value, and this is your y value. What we're ultimately trying to find is a point, an xy coordinate that partitions a line segment a certain ratio. So my end calculation is going to be an xy coordinate. All right, so let's go ahead and just do this example that I have. All right, so let's do the x value first. And this is my x value formula. So b times x1, so 3 times 0, plus a times x2, 2 times 2, all over b plus a, 2 plus 3, or 3 plus 2. All right, when we simplify this, 3 times 0 is 0, 2 times 2 is 4, and 2 plus 3 is 5. So I end up with an x value of 4 over 5. So that's going to be the x value of my point. And now the other step is doing the y value. So y is going to equal, and we use this side of the formula, b times y, b times y1, I'm sorry, so 3 times 1, plus a times y2, which is 3, all over b plus a, which is 5. All right, simplifying this, 3 times 1 is 3, 2 times 3 is 6, all over 5, and 3 plus 6 is 9. So my final y coordinate is 9 over 5. Now you guys can keep these as fractions, or you can convert them to decimals. It's up to you. I'm good with that. So this is my final point. This is the point that partitions this line segment in a ratio of 2 to 3. All right, go ahead and go on to the next video.